Good morning, my dear students. So last session we have started solving this problem, uh, which is continuous beam with fixed ends. Okay. So let us see the further solution, what is left over from the last session. So we have solved for this part, moment distribution procedure we have completed. We have found end moments. Okay. Then now it is our job to complete the remaining part, that is BMD, SFT, and also to draw elastic curve. Okay, so let us take up that one. So I'll straight away go to the result that we got in the last session. So moment at A in AB is this value, and moment at B in AB, moment at B in BC, moment at C in BC, right? So these are the values. So first let us draw them, then we will take up drawing BMD. Okay, so see here, negative sign means anti-clockwise moment. So A has got anti-clockwise moment, you see it here. So A has got anti-clockwise moment of value 107.4. Okay, so A was actually fixed support. So now you see I have drawn a partial free body diagram where I have not completely removed fixed support. I have removed only moment reaction from fixity. Then I have kept vertical and horizontal support reactions in terms of hinge support. So I have kept a hinge there. So there are two reactions for hinge. So I have kept hinge and separated moment from it. Okay, then what next is, so B moment at B is 55.2 clockwise because it is plus value. Okay, so clockwise 55.2 clockwise is drawn. So here I have kept a roller just to indicate the simply supported beam. Okay, because the original support there is continuity. So what we are doing, we are breaking the continuity here. So we are taking AB separate, BC separately. So you are breaking the beam there, but there is a hinge support there. Okay, so that is what is here represented. Either because it is a beam, whether you keep hinge or you keep roller doesn't matter. So just for our conventional notation, that a simply supported beam should have a hinge and roller. That is why we are now showing a roller here. Okay, otherwise there is not much difference theoretically. Okay, right. So now left support A has got 107.4 anti-clockwise, right support has got 55.2 kilonewton meter from, these are end moments called end A, end B moments. These moments are calculated from moment distribution method. Okay, so by this time you shall understand moment distribution method is used for getting end moments. Okay, right. So what is there next? The other load you have is UDL 30 kilonewton per meter is also there on AB, so that is also drawn here. So this is AB simply supported beam with end moments and load. Okay, right. Coming to BC, support B is having minus 55.2. Negative means anti-clockwise, and 52.4 at C, positive value means clockwise. So draw those two values. So anti-clockwise 55.2, clockwise 52.4, okay, for BC beam, and other loads that it is having, applied loads 72 2 meters from C. Okay, so that is also drawn. Now there are two simply supported beams with moments and UDL, and moments and point load. For this you have to draw BMD. See, remember, you have to draw the support B one below the other. Okay, which means if you join those two, right, this minus 55.2 and plus 55.2 gets cancelled, and you will get again, you are going to join the beam again. So continuity is maintained. Once you break that continuity, then you will see the moments. Okay, so this 55.2 is because of that continuity in the beam. That is the reason. Okay, right. Now how to draw BMD for AB? First let us talk about it. Same as usual. If you remember, the drawing BMD for indeterminate structures, we will draw first support moment diagram, support moment diagram. Then we will overlap span moment diagram. Okay, this is what we follow. Got it? So now come here. So support A has got anti-clockwise, means what? It is hogging, negative moment. Okay. Again, if I recall that I told you that when you draw support moment, negative values above reference line, positive values below reference line. Whereas when you draw span moments, positive values above the reference line, negative values below the reference line. So this is a rare case. Also, this is a rare case. Okay. So in general, support moments are negative, span moments are positive. Okay. So above the reference line, when you are drawing support moments, above the reference line, you should draw negative values. When you draw span moments, you should draw positive values above the reference line. Same you follow. So first, let us just take AB portion. Okay, just AB portion. So 107.4 negative. Why I am calling it as negative? Because that 107.4 is trying to bend the beam upward, means hogging. Okay, or else left of the A, sum of all moments to the left of A, if you see, left anti-clockwise negative. So that is why this. So draw 107.4 ordinate at A. Next, come to B support. Only support moments you should draw. Don't consider this 30 kilonewton per meter. Same, sum of all moments to the right of B, you have 55.2 clockwise. So right clockwise is also negative, beam notation. So draw 55.2 at B. Just join the both values. So this is negative BMD. Okay, this negative BMD. So this is negative. Now draw span moments. What are span moments? It is a simply supported beam with UDL. So you will get a parabola and maximum value will be at center. The value of maximum bending moment is WL square by 8. So that is this value, 135. So just draw parabola, 0 at A and 0 at B. Draw parabola with maximum 135. So this is positive. This is again negative. So this completes AB bending moment diagram. Similarly, BC, same procedure. Support moment 55.2 minus. So 55.2 minus. Then 52.4 minus. 52.4 minus above the reference line because they are support moments. Just join both. This is negative bending moment diagram. Negative here. Negative. Now positive bending moment diagram. It is a simply supported beam with point load. So under the point load, we will expect maximum bending moment, and the maximum bending moment value, it is eccentric point load. So formula is P A B by L. That is maximum bending moment for a simply supported beam under eccentric point load. 72 into 4 into 2 divided by 6. That is coming to 96.0. So this is positive. Okay. So this is the BMD. This is the triangle that you should draw. 0 at B because simply supported, 0 at C, and maximum at under point. So this is how we draw BMD. Remember, when you draw BMD for indeterminate structures, we are following overlapping or superposing support moments and span moments. In other words, negative moments and positive moments we are overlapping, and the remaining area we are showing by hatching of 45-degree hatching. That will show you the net bending moment diagram. Okay, right. So only the hatched area is our net bending moment diagram. This empty area is not there in the BMD. Okay, so bending moment values are 107.4 at A, and they are reducing slowly, and here they are becoming 0. Then again negative values are becoming positive values, and the values are increasing. They are becoming maximum, and then they are again becoming 0. Then positive values again becoming negative values and coming to 55 point. Likewise, the other portion also is becoming 0, negative to positive, again becoming 0, positive to negative. This is how the bending nature is. Okay, right. So let us go for shear force diagram. How SFD will be drawn. Okay. So unlike bending moment diagram, we cannot separate support moments and span loads for shear force. Shear force cannot be separated and overlapped. You have to draw shear force diagram as a single one. Okay, yeah. Right. So for which you need support reactions, then only it is possible. Okay. So how you get support reactions? It is you can use regular procedure of sigma fy0, sigma m0, likewise, or otherwise you can follow short way of calculating the shear forces. Okay, I call this as VB2. VC, because VB has got two values. Okay. So how you perform this in short way? I'll just show you how it can be done. Okay. So first, let us take UDL. What will be the reaction from UDL? So what is total load? 6 into 30, 180. Okay. Half of the load goes to support A. That means 90, equal share for both the supports, 90 and 90. Okay. So UDL, total load is 6 into 30, 180. So half the reaction to one support and half the value to another support. This is reaction from only UDL. What about moments? Calculate total moment. This is anti-clockwise 107.4, clockwise 55.2. So what happens? 107.2 minus 107.4 minus 55.2. So 52.2 is the net bending moment value. 52.2. Which direction? Which is more? 107.4 is more. So anti-clockwise. So this is anti-clockwise moment. 52.2 is the total moment in AB. Okay. Right. Applied on AB. From this, what are the reactions you should get? So reactions should develop equal amount opposite direction. Means what? Clockwise 52.2 shall be there from reactions. So clockwise 52.2, if you should get, what happens? Clockwise moments can be produced with the support reaction directions: left upward, right downward. Left upward, right downward can only produce left upward, right downward. Only produce clockwise moment. Okay. So what is the value of force required for producing 55.2? Is equal to, force is equal to moment divided by span. Span how much? 6. So 52.2 divided by 6, 8.7 is the reaction. Okay. So it is like a couple. So 8.7 is the force and distance is 6. So 8.7 into 6 comes to 52.2. So these are the reactions total at A and B that develop because of UDL and because of moment. So what is total reaction at A? Both are in the same direction. So 90 plus 8.7, 98.7. These are opposite. So 90 minus 8.7. What it will be? 81.3. Okay. So that we are drawing it. So draw 98.7 total VA value. Then there is UDL. So total UDL when you reach B, it will be 180. So 98.7 minus 180, it will be 81.3. But you have 81.3 upward force here. So reach 0. So this is AB SFD. Because you have UDL, that's why you are getting linear line. Okay. Right. Next, going for BC. So you have 72 point load. So how much you get the reactions VB2 and VC. So from 72, the reaction is 72 into opposite distance 2 divided by total span 6. This is the value. 72 into 2 divided by 6. 24. This is 24. So minus 72. I mean 72 minus 24. How much? 48. This is 48. Or you use the same formula 72 into 4 divided by 6. Okay, that also will give you the same. So these are reactions from load 72. What about reactions from momentum? This is 55.2 anti-clockwise. Clockwise 52.4. So both are opposite. So you have to deduct 52.4 from 55.2. It is 2.8. So total moment is 2.8 only. Which direction? Whichever is higher. So 55.2 is higher. So that direction is anti-clockwise. So 2.8 anti-clockwise is the total moment acting on BC. So you should develop clockwise 2.8 to balance that one. So reaction should develop like this. So again, clockwise reaction will be developed only by left upward and right downward reaction. Left upward reaction, right downward reaction. What is the value of force? Moment divided by the span. 2.8 by 6. 0.47. 0.47 kilonewton is the force value. So this is 0.47. Is also 0.47. So what is total reaction at B? 24 from load, 0.47 from moment. Both are in the same direction. So 24 plus 0.47. 24.47 is this ordinate. Then there is no load till point load. So straight line, horizontal. Then there is 72 there. So come down by 72. So you will reach minus 47.53. And again there is no load here. And there will be reaction of 48 minus 0.47. It is 47.53 upward and reach 0. That's it. So this is SFD for BC portion. Because there is a point load, there is sudden jump. And all other locations, it is horizontal line. Okay. So this is how we draw SFD. Okay. This is all we have practiced very much in case of slope deflection method. Again, we are doing the same practice here. So do refer if you still have some doubts about drawing SFD and BMD, your slope deflection method notes. Okay, lectures. So this is how you practice moment distribution method procedure, finding end moments, as well as drawing BMD. Always the indeterminate structure BMD will be drawn with the principle of superposition, superposing positive moments over negative moments. Okay, and SFD is as usual. Okay, and now how you draw elastic curve is with this diagram. If you have BMD, you can easily draw elastic curve. You see, there is negative moment from support till some distance, and then there is positive. So here, from here to here, it should be hogging, then after that sagging, again hogging. Okay, so let us go to the structure here. So till some portion there is hogging. Okay, this is the curve like this, and then it should be having sagging again from here to some distance, sagging, then again it is becoming hogging. Okay, so this is the elastic curve, means deflected shape of the axis. So this is the curve. Then what about the other portion? Again it is having some hogging first, 0, sagging again, then again 0, hogging, but little far away from the support. I mean to say far away from the support. The 0 point is far away from the support, which means what? You should draw hogging little bit higher. Okay, then very less portion of sagging. Okay, you see, very less portion of uh, sagging, little almost equal portion of sagging, and very little portion of hogging here. So very little portion of hogging here. That's it. Okay. So this is how we draw elastic curve. So with a simple observation of BMD, you see this portion you have hogging. This portion sagging, and again this portion hogging, negative moments. Okay, because this area is part of trapezoid, it is out of parabola, right? So part of trapezoid, that's why trapezoid is for negative moments, and this is part of parabola, means positive moments. Okay, likewise. So same here, the other portion also. Likewise, you can draw the elastic curve easily by observing. You can see here very little hogging portion, more of sagging. Same is observed here. You see, little hogging, more of sagging. But whereas here you can see that hogging and sagging are of almost equal length. Then very little hogging portion that is drawn here. Okay, this is very little hogging portion, and sagging here means very, and these two are almost same, hogging and sagging portions. Okay, this is the curve for hogging that we draw. This is the curve for sagging portion. So likewise, you can combine all these hogging and sagging portions, you will get elastic curve. Okay, so this is how we draw elastic curve. Okay, like this. This is how you complete this solution with respect to moment distribution method procedure to find end moments, as well as to draw BMD, SFP, and elastic curve means deflected shape of the beam. That's it. So zero bending moment here, because zero bending moment as well as zero deflection at B, zero deflection at A. There is a support. Wherever you have a support, you have zero deflection. All other portions you will find deflections. Okay. Right. Thank you. We'll come back with some more examples.